Okay, this is the same day recording. I just stopped it earlier, but we'll go back and sort of review how we started it. Started with the components list, same as last time: ethanol, methanol, propanol, butanol, and NRTL is our basis for the same reasoning as the last recording. So yeah, let's just hop straight into the simulation here. Uh, let's see, open the model palette real quick. Oh, it's not. Oh, there you go. Okay, sorry. Couldn't open it for some reason, but it finally came up. Yeah, let's just add a material stream here. This is gonna be a lot like the first one. Just naming it feed, giving it the basic properties. Two from the problem. Composition is again the same as before. 20% ethanol, 30% methanol, 15% propanol, and 35% butanol in mole fractions. Then for the temperature, it says that it's subcooled and below the boiling point. And from the other problem, we saw that 83 degrees Celsius the boiling point. So I think we can just go with something like, I don't know, 55 should be a good reasonable estimate there. Um, sure. Okay. And then do I need anything else here? Oh, a flow rate. Yeah. So the problem says that we want something, a feed with 100 moles per hour, but it should scale the same way if you do 100 kilomoles. We'll just have to take that into account later when we do the column. So yeah, the feed's all good there. Gonna go distillation column. Again, let's put this feed in. It's gonna assume middle of the tower, fine. So we want the, let's see, uh, we want to specify these things. So the overhead is the distillate, this is the waste. Of course, give it the energy streams names, fine, all fine. And keep that the same. Gonna use the same settings before. I think I can get away with. No, I guess I can't. So again, sure. Oh, actually, should I be doing this? Really, no, it doesn't specify anything about this. There has to be some pressure gradient along the column for it to make sense. That reflux ratio there, 3. So let's see, let's go straight to our monitors. And we set our reflux ratio to 3. And then we also know that we want our, what is this? Bottoms production rate. No, sorry, wrong one. We want our component to be just like we did before. So we're going to have this again. Oops, got really big. So let's see, out of the distillate, so out of the condenser, we want 95 mole percent methanol. So let's change that. 95. That's all fine. I'm gonna set that to active. One more, and we want the component fraction to be 0.05 out of the reboiler. Methanol. Okay, So we set those two here. Degrees of freedom is too much. Why? Um, this is active. Sure. Okay, I think because I already set the reflex ratio to 3 earlier, it was defaulting around that. Let's see. Or was it not? It shouldn't be. Go back and change that thing actually. I don't know why. Monitor. Okay, I think that's fine actually. But why are we so overspecified? Because I can only specify one. Let's see. If I put this at 95, see what happens. No, I think we're gonna need a higher reflex ratio. Yeah, it's just unconverged. Let's see. If I set this up to estimate. Yeah, it's weird. If I set that up, that works fine. It's a 95 and 5 there. So composition, yeah, so that one's fine. Um, yeah, so the composition of our outlet distillate here and the waste are right here for both of those. If you want to see the properties of the streams, we have distillate flow rate about 22.73 and this at 11.7, which is a little lower than I thought. Should have been a little higher, but the balance looks to be working. Wait, no, sorry, that was the density. I don't know what I was reading. It doesn't make sense. Uh, Here we go, molar flow rate. That looks more right. Okay, 100 kilograms, kilomoles per hour. This one's 27.78. That looks right. And again, 72. These should add together to get that one. That works out right. Temperatures look about right. And we remember we wanted just the specified compositions to be 95 and 5, which they are. Um, and this is a 10 tray column. Uh, so that's the amount and composition for the 100 mole. It's problem A. We wanted the top and bottom stages and the number of stages. I think that was fine already. We found that. Um, P4. I think that's all I needed here. I don't really know if we need to do anything else with this problem. You want to find the minimum reflex ratio? Do we need to do more stages? We might have needed more stages, but we're at 10 right now, so I think it's about the minimum. So yeah, if we go down one. Oh, 9 seems to work. What if our reflex ratio is higher? Yeah, that would make sense. What if I set this here? Yeah, I don't know why. Let's see. Need to go to the tower. I think maybe I messed something up when I did that. When I set that thing to 3. So let me try this. Just restart a little quickly. Feed. distillate, waste, QR, C. I don't know if that really matters right there. And then distillate 1.32. Sure. Next. Yeah, let's not set that reflex ratio there. Let's see what happens when I change the specs here. Set this to 3. Oh, it's a vent right now. Interesting. No, I think I need to put that in liquid. Let's take this out the condenser again, try it again with methanol. Liquid. 5. I know this is going to be vapor, isn't it? Yeah. Oops. Hold on. Wrong button there. Let's see. This one's taking a lot of steps to solve, and it's probably because there's not enough stages. Yeah, it's getting really close to 95. This looks fine. Let's see what's wrong with that. If I add one more. 13, lucky number. I don't know why this isn't solving. It should be solved. It's weird. I don't know why it's taking so long. Where's that thing that says solver? That converged fast. Yeah, okay, there we go. I just set the limits a little bit less specified, but it's more of an estimate now. But this seems to have worked. Let's see if I change the lower now. Yeah, that looks about right. I think I just need to set the limit a little lower. It's a little bit better. Yeah, okay. So if we set this thing for total reflux, which is what the second question asked, what's the temperatures and the number of stages? So that works. Oops. Distillate, right? Let's go to 10. Stop. Let's run it at 10. It's still not solving there, which is a little weird. It's back. Move this down. Yeah, okay. So that seemed to have worked. If I just set the tray down one a little bit. Yeah, good. Good. Let me just check the composition of that one. Yeah, well, methanol. Oh, this is like 30%. Yeah, this is not what we want actually. Why is this saying? Yeah, outside the condenser should be 95. Oh, here it is. That's why. That might not solve. Let's take off the reflex rate and just do it the way we did first. Let's put this at 0.05 to just guarantee that we meet those fractions. Liquid 5. Yeah, so now we have 0 degrees of freedom. Should be able to run that. There you go. So our reflex ratio went up, which is fine. Sorry, looking for worksheets. Yeah, so this one we hit 95 and 5, which is good. Our molar flow rate looks good here, so the same. We hit this with how many stages again? This one was 10. See if I go down one if it hits. Yeah, results seem to have stayed the same. So I think about 9 minimum stages here is fine. And then we wanted also to, I guess the problem statement that was given was side stream. Yeah, I mean the side stream was kind of the same as the first one. So let's add 20% water to this problem and do a little experiment with that one. So let's hold that. Go to properties here. Let's go back to the component list. Water. Okay. So 20% water. Um, and let's say that this feed. How is this going to work? Okay, so that fixed itself out. So if I had 20%, it balanced there. And what's a flow rate? Okay, sorry, I just had it on hold. There we go. And let's do either this or this. So we added the water in these streams. So now if we look at the column, looks like it's already being solved here. Check the 95% on the top, percent on the bottom. Specs. Check the worksheet real quick. So yeah, the molar flow rate went down in the distillate. This one increased slightly in the waste stream. Um, The actual compositions remain the same here, 95 and 5 here. There's a lot less water and honestly a little more ethanol in the waste stream, I think, than the last one. Um, so if we were doing something specific, so these are the compositions with 100 kilomoles or moles per hour feed and the amounts which we needed for the problem right here. And then the temperatures, yeah, right here, 65 and 85 degrees Celsius with the water. And then we wanted number of stages at total reflux, which we got to be 9. So 8. Yeah, this one might go on for a little bit. Okay, I don't think this one's gonna solve. So it looks like 8 was fine. The total reflux, so went down from 9 to 8. Interesting. Um, feed. Maybe if I move the feed, actually, it makes more sense. Yeah. Okay. So anything else I need to do? Number of stages, feed tray location. You didn't really get to choose that one. Maybe if I change the spec for that instead. No, it wasn't. We didn't need to do that. I think that's about it, actually. I don't know if there's anything else to do. It looks successful to me. It converged and it separated what we wanted to 95 and 5% methanol. I guess I could do the side stream too, actually. If that, yeah. So side draw, side. Let's take it out the tower right there. Let's go to the monitoring room. Set S rate. Set it to 10. See how it goes there. So we set to 10. We're gonna try to reach. Let me just monitor on the screen. It'll be a little better. And that's coming out of upstream L4 main tower. We want to monitor the ethanol to again get a good amount there. Yeah, so that's at 23. Let's see if I go to 15. It's going to change up. It's at 22. Let's go to 20. Five. Yeah, looks like it's not changing there. So if we want this to be there, let's move this feed down a little. And then let's say that this is coming from 2. Let's monitor this one. From 2. Again, we're looking for the ethanol. Okay, interesting. Got less. Oh, there you go. Just, oh, that's unknown. Yeah, we might need more units here to separate these two. That makes sense. Just to get our optimal going. Yeah, let's put it at 5. That thing's a huge flow rate. Not gonna work. Let's keep going. See what happens. Getting a little higher, but still not ideal. Just spiked. No, didn't converge. So let's try changing that thing to 5 and this to 7. See if that works any changes into it or not. No, it doesn't look like it. Hmm. Went over 20 there. Let's again check our. Where is that? Parameters. Oops. Yeah, sorry. Let's turn on. Let's check our solver. This is okay. That's weird. I feel like it should work. Hmm. This. Sorry for our rates too huge. Um, Let me change where the feed is again. Let's put it at 9. Total reflex in the condenser. Shouldn't this be? Um, let's see. If the water is making this more complicated to separate. Um, So ground connection, this should be coming from stage 5. Should be fine. I just want it to be higher than the feed, I think. So instead of doing this, let's turn the flow. See, that's at 11% ethanol. That's on our worksheet. Yeah, that's. Oh, wait. Our side stream is actually getting 24. I'm monitoring the wrong. Oh, I never set this to change. I keep making that mistake. Yep. Let's monitor this one for ethanol. But 25 years. So if we actually just move this up a little bit, we should have around something a little bit better or not. Yeah, it's around 25%, which should be a little enriched versus what we have. See if I go even lower. Okay. Yeah, that doesn't look too bad. So we have 25% there, and let's check our feed or our actual numbers here. Uh, yeah. So our ethanol came in at a higher percentage than in the feed because it's 16. We enriched it to 25%, giving it a 10% mole boost here in the side stream. So that could be taken, and the butanol and propanol are both trace. So we really just have ethanol and methanol to separate if we took that side stream, which I think is desirable in that scenario. In this column that separates like the 95 to 5% still between the methanol, between the distillate and the waste. So looks okay. Yeah, it should be good. All right, I think that looks good. So